So we're given the graph of the velocity of an object, and what you need to know is if we integrate the velocity of an object over some interval, we will get out its displacement over that interval. Displacement can be either positive or negative. If you have some positive displacement and then some negative displacement, those displacements will cancel each other out. The other thing that you need to know is that we can get the distance traveled of an object over an interval a to b by integrating the absolute value of its velocity. One more thing, if an object has a positive velocity, that means it's moving in the positive direction, usually that's up or right. And if an object has a negative velocity, that means it's moving in a negative direction. Typically that would be down or left. So if we're asked on what intervals is the object moving in a positive direction, what we have to do is go to this velocity graph, and you can see that velocity is positive when our time is between 0 hours and 1 hour. Also, we have a positive velocity when our time is between 3 hours and 5 hours. So we're moving in a positive direction from t equals 0 to 1, and also from t equals 3 to 5. At t equals 1, 3, and 5, you'll notice that our velocity is actually 0, meaning the object is not moving, so we'll leave t equals 1, 3, and 5 out of this interval. Sometimes with interval notation, you can connect intervals with a union, or sometimes you're asked just to put a comma in between your two intervals. Okay, next question. Find the displacement of the object on the interval from 0 to 3. The displacement that we're looking for on the interval from 0 to 3 is just going to be the integral of our velocity function from 0 to 3. Now, we don't actually know what the velocity function is, but we do have these areas given to us. So between t equals 0 and t equals 1, we see that our object is moving in a positive direction, and it moves a total distance of 15 miles. However, when t equals 1, this object stops, and after t equals 1, the object starts moving back in the negative direction where it came from. And between t equals 1 and t equals 3, that object moves a distance of 18 miles in the negative direction. That means that our object moved 15 miles forward and then turned around and moved 18 miles backwards. The total displacement of the object then is going to be negative 3 miles. That would be movement of the object 3 miles in the negative direction. Last, we're asked to find the total distance traveled on the interval from 0 to 3. Now, from the discussion of part 2 of this problem, maybe you understand that while when it comes to displacement, we do have positive and negative direction. When it comes to distance traveled is always going to be positive no matter what direction you're traveling in. So between t equals 0 and 1, our object travels 15 miles, and between t equals 1 and 3, our object travels 18 miles. We can just add those together to get our total distance traveled, or slightly more mathematically, we can set up an integral from 0 to 3 of the absolute value of the velocity function. We can split that velocity function into its positive piece and its negative piece. While the integral from 0 to 1 of this function is going to be positive 15, the integral from 1 to 3 of this function is actually going to be negative 18. So if we want the distance traveled, we're going to subtract these two. That would give us 15 minus a negative 18 for a total distance traveled that we mentioned before of 33 miles. Okay, I hope that this helps you out a little bit in understanding the difference between displacement and distance traveled. We will talk more about position, velocity, and acceleration in the next video, so I will see you there.